Good day, everyone. Thank you for taking the time to join us today. We have a busy schedule, and my session today just to give you an overview on the Gigamon Inline SSL decryption. We'll have a lot more deeper dive sessions later in the day, so this is just a teaser. Hopefully, you can join us later on in the day. Again, my name is Rami Ramaha in product marketing. And in the next 25 minutes, I will provide you an overview of the inline SSL decryption solution and the challenges behind driving the solution. We have experts online, so I encourage you to ask questions, and in the chat window, we will address them as they come in. So first, before I dive into the challenges, let's look at the drivers first. When we talk to enterprises, the first question that we get is, why do I need to decrypt? But if you look at the percentage of traffic, encrypted traffic, it's about 80% or higher. And that gives organizations false comfort feeling that if the traffic is encrypted, then we're safe. In reality, 50% of malware used encrypted traffic last year, and this year is going up to about 60%. And since COVID-19, there was an increase in cyber crimes, and the reported number is about 300% or higher actually nowadays. And so if you've got 80% or more of your traffic that's encrypted, and 60% of the new malware is using encryption, I think it's fairly obvious to say that you need to pay attention to having visibility into encrypted traffic. Yet at the same time, as of last year, Gartner is saying even in 2020, 60% of organizations will fail to effectively decrypt that traffic, meaning that they may not do it well, they may not have the tools to do it, or they may not have visibility into all traffic. The other component I want to highlight is about the decryption version that's being used. So we at Gigamon did a survey not too long ago, and we found that 81% of north-south traffic is encrypted, and majority uses TLS 1.2. while 56% of east-west traffic is encrypted, and again, majority is using TLS 1.2. And the latest TLS 1.3 version that became available not too long ago, back in August 2018, to address many of the security and performance shortcomings of TLS 1.2 is picking up momentum. And this is across, we've seen this across the industry, and this is in line what Qualys Labs SSL Pulse data findings actually reported as well. And that's exactly why Forrester said you have 2 years to prepare your security tools for widespread adoption of TLS 1.3 and DNS over HTTPS. So the expectation is that these two foundational protocols of the internet, TLS and DNS, have recently undergone radical changes to protect user privacy and content. At the same time, these changes hide valuable metadata from enterprise network inspection tools, so security monitoring tools will be blinded to the content and destination of traffic and unable to detect threats. So preparing today and start taking actions for the widespread adoption of TLS 1.3 and DNS over HTTPS is critical to protecting your network. And when we talk about encrypted traffic, it is viewed in a couple of different perspectives. So we have a variety of users, both internal and external users. We have internal resources, we have public cloud resources, and we have the DMZ resources in between. So the first use case I will talk about is inbound. And these are external users that are coming into your server farm to your web servers that you are controlling and hosting. And you obviously want to have a decryption zone and have visibility into that traffic. The second is what we call outbound services. This is where enterprise users initiate traffic out to the internet, the public cloud, and that's typically as part of a security content inspection zone. And the third use case is internal services for east-west traffic. So as malware initially makes its way into the network and establishes command and control, one of the first things that does is tries to do lateral movement to move throughout the network and gain a foothold and other resources. So for today, I will focus on the two primary use cases, inbound and outbound services. So typically in the inbound scenario, you are looking at an architecture that might look like this. Traffic coming in from the public, hitting your servers, and perhaps you have a web application wirefall, a WAF, and an IPS, or one of the other. You have some challenges here. These devices are in serial. They create single points of failure. They can cause performance and throughput issues, and it's really kind of difficult to change and add because these are hardwired in serial into your network. Plus, the WAF processing, the web application firewall processing, tend to be fairly expensive. So if you are doing decryption on a WAF box, you are using a very expensive box to do a decryption function that could be offloaded so that you then free up a large part of the processing power of your WAF to do that inspection as opposed to decryption. Pretty much the same scenario for outbound. We have serial devices, single point of failure. All these tools must see the same traffic. There's no load sharing capability. They've all got to have the same port speeds, and it's difficult to ensure throughput and manage. So when we look at what your options are, the first is you do nothing, and based on statistics that we saw earlier from Gartner, we do not believe this is the right approach. The second option is to enable decryption on each security tool. And based on third-party assessments and lab tests of these security devices, you lose anywhere from 30 to 70% of your threat detection throughput. For example, if you have a 10 gig threat detection device, becomes about 3 gig after it loses 70% of its threat capacity, protection capacity. And if you have multiple devices in your security stack doing decryption and encryption, that may lead to other problems like increased latency and difficulty to troubleshoot. Now, the third option is inserting a standalone decryption appliance. This approach does not help in collapsing your security stack and adds more complexity to the mix. Here in the last option is using a Gigamon visibility and analytics fabric. You get network coverage of flexibility with an inline bypass being able to decrypt once and feed any number of inline or out-of-band devices with rich service chaining and resiliency for all of those tools. And to enforce the Gigamon approach, According to the NSA Cybersecurity Information Report, it is recommended to do it well and do it once. So to minimize, so what does that mean? To minimize the risk of breaking and inspecting TLS traffic, it should only be conducted once within the enterprise network. Now, redundant TLS inspection, wherein a client server traffic flow is decrypted, inspected, and re-encrypted by one forward proxy, and is then forwarded to a second forward proxy for more of the same, should not be performed. Inspecting multiple times can greatly complicate diagnosing network issues with TLS traffic. Also, multi-inspection further obscures certificates when trying to ascertain whether a server should be trusted. Again, I want to remind you, if you have any questions so far, please put them in the chat window. We have, like I mentioned, folks online who are can answer them as they come in. So let's look closer at the Gigamon solution and see how it works. Typically in an organizations, we have this network and everything is working fine. And then the security folks come in along and say, hey, we want to stick these devices in here because we've got to protect our enterprise from breaches and attacks and the threats that are out there. So we may want to put in an IPS or a WAF or some other advanced threat protection devices, and maybe we actually need to have 2 or 3 of those in parallel to handle the load of the traffic in our network. So how do we do that, and what are the concerns? So initially, the network owners have concerns about reliability and the availability and throughput, and all the things they've spent a lot of time focusing on to build this network, and now at risk, now put at risk. So they want to know, how can they bypass if it doesn't work, and how do I fix it and do maintenance on it going forward when we need to. So on the flip side, the security owners are worried about all the different links that are in this network. How can I ensure that I have my inline inspection on all these links that these network forks have put in there? And by the way, I may only want certain tools to see certain traffic and not all the traffic, and I've got to load share across these old one-gate tools that I still have them. They still work, and I do not want to buy new ones. So I want to load share, and I want to be sure that it's resilient. And if my tools have problems, I can do things like activate a hot spare and even put this in a passive mode first to monitor what's happening, and then flip the inline when the time is right. So this is where the Gigamon inline bypass helps the network owners run fast while the security owners stay secure. Now, again, this is accomplished with our inline bypass capability. It's a core part of the GigaView operating system. There's no license for it. You buy a product, it's got ports on it. You can implement inline bypass through configurations. And what you see here on the left is a simple example. I'm just showing one set of links here. This could really be multiple links, where if I were to try to put those devices in, we would have to figure out how to put them in parallel, and they'd all be in series and have all those problems. On the right hand, side is what it actually looks like from the connectivity standpoint with our HC series. The first is the single insertion port point. We put Gigamon inline, and we have the option of the physical bypass protection ports, so that if there is a total power loss, catastrophic failure, that's a failure to wire mechanism. It's a copper or optical relay that will close that path and allow the packet to continue to flow through the network. So this helps supporting mixed media link and speeds. So you may have all 10 gig network today with 10 gig tools, but you want to upgrade your core to 40 gig, but you don't necessarily want to have to go out and buy 40 gig tools. So now we've got 40 gig core or 100 gig core and 10 gig tools, or maybe you've got a 10 gig core and you still have a mix of 1 gig tools, like those 3 FireEye ATP boxes that you see on the diagram. You can put 3 of those in and load share at 1 gig. And of course, we can do logical bypass as well. So which means if any one of these devices, we needed to route around it, we can bypass the device and do all of this just with software configuration. Now this shows all of these devices just connected to any port. Doesn't matter where they are connected, connect them into a port, and we create the flow maps that will steer the traffic. And with the flow mapping, we create all the routing to steer the traffic that we want to be sent to each tool. When the devices are connected, in order to create that resiliency, you have the option of enabling health checks and then taking additional action on failures. So we have a series of positive and negative type of heartbeat that can be generated to these attached tools. And if one of them is detected to be not functioning or down, then you have the option in terms of what action to take around that tool. And these tools are attached. You can have a single tool. You can have tools that are in series, logically in series, because they are just attached to ports, and we steer the traffic through in whatever order is necessary, or have them in parallel to do load sharing with N+1 arrangements. For example, those ATP boxes on the bottom could be 2 active and 1 spare. And if one of the active devices failed, Gigamon would detect that and could automatically swap in the spare device and continue to pick up the load and processing where the other one left off. Of course, link coverage that we mentioned, this could be for many links to one tool. It could be one link to one or many tools, or it could be many links to many tools. That's the power of a packet broker and the power of our inline bypass being able to solve this very hard and very real problem, getting many links to route traffic through many tools and to keep all of that traffic in line. And of course, the SSL decryption engine as part of the processing, so that it would decrypt select traffic once and feed multiple copies to inline and out-of-band tools like NDR or bypass certain traffic and feed it directly to the tools without decryption. In situations where sensitive information needs to be hidden for privacy and regulation reasons, like credit card information or PII, personalized identity information, we can apply masking on these bits before sending to tools. So by offloading decryption, we are extending the life of the tools where the threat inspection capacity of these tools is not degrading. And according to independent industry reports, the degradation can be up to 70%. And the other beauty about offloading and centralizing decryption in Gigamon device is that it reduces latency because you don't have to decrypt and encrypt multiple times, and it makes troubleshooting much simpler and easier. And it's all managed through our UI Fabric Manager with a full RESTful API to take advantage of functionality from external systems. Let's look at how we can do this in the Fabric Manager. So building an SSL decryption configuration can be done through CLI that we have on the device, but you get the most value out of Gigamon Inline SSL by using our flexible inline arrangements with this drag and drop approach to configuration management in the Fabric Manager. So here you'll see on the left-hand side in the upper half how we want to treat traffic coming from production network before it exits on the right-hand side. And the lower half is the same exact maps as the upper half, but traffic going in the opposite direction, right to left. So for example, here, the first map on the top is a privileged traffic that we do not want to decrypt, so we just pass it through. The second map is the traffic we're targeting for decryption. So the two GS boxes, the GigaSmart boxes, make up our decryption zone. Then you just drag and drop the tools you want in that decryption zone. A copy of decrypted traffic is then made and can be sent to an out-of-band tool. The third line map is for any remaining traffic that we did not target for decryption, but still we want to send to that tool and make a copy. And finally, the fourth line map is the collector to ensure that any remaining traffic that did not match any of our maps gets passed through from left to right, or A to B. IT can build this from scratch very quickly in about 10 minutes. So just looking at how we manage the keys for inbound and outbound deployments, there's a little bit of key management involved here on inbound. We are actually front-ending the servers and acting as a reverse proxy. So the local keys that you will control would be installed, and we would then front-end that, spoof the servers so that to the outside world, everything looks good. There is no trust issue. There are no browser pop-ups. Everything is taken care of. Compared to an out-of-bound mode, where we do not have access to the key for all the public web servers that are out there. So we have to re-sign their certificates for each session that the users initiate, and we do that by establishing trust on the internal clients, and then acting as a man in the middle so that as a decryption occurs, everything is accounted for. There are no pop-ups, no browser warnings. A man in the middle is where we are today. It is required for TLS 1.3 It is required for perfect forward secrecy, PFS, based cipher suites. It supports inbound mode for public-facing web servers, outbound mode for enterprise user traffic to the internet, and internal deployment mode for user traffic to internal servers and inspect east-west traffic. So just I want to summarize what I talked about. The Gigamon visibility and analytics fabric allows IT to implement TLS decryption, including 1.3 version, very easily without any rewiring of the architecture. It ensures no encrypted traffic slips through without inspection. We give you this highly flexible and simple UI that you can do drag and drop of the traffic that you want to decrypt. Makes it extremely efficient and powerful to monitor the traffic. We give you this centralized decryption and re-encryption function. Again, this is all based on the recommendation of the NSA advisory report that I just shared, that distributes this decrypted flows across tools. The Gigamon visibility and analytics fabric enables this fast inspection. It simplifies the security stack, it accelerates troubleshooting, and it increases the tool's efficiencies. So organizations will be able to reduce their operational costs, as tools would not need to be updated as frequently, and enforcement of regulatory compliance will allow for smoother and faster running tools. And your operations teams, the NetOps, the InfoSec, the Cloud Ops, all these teams are empowered with consistent and advanced visibility and analytics for all traffic, including the encrypted flows across, the networks that you could have, whether it's a private and the public, that decreases the implicit trust and drive a smoother journey to a zero trust architecture. I want to thank you for listening and taking the time to listen. We have, as I mentioned, we have multiple sessions throughout the day that will dive deeper into the inline SSL decryption. Please attend the ones that fit you best, and please visit and join our Gigamon community to stay up to date on latest releases and discussions.